Hello, class. This is week 4, and I am Dr. Neil Sogi. And this week we're going to be taking a look at intelligence. And so I think it's good to start off with a few jokes. And today I want to just do a few one-liners on intelligence. First one. Maybe if we started telling people the brain is an app, they would start using it. Intelligence is like underwear. It's important that you have it, but not necessary that you show it off. A conclusion is the part where you got tired of thinking. And finally, love is the triumph of imagination over intelligence. And that's it for the jokes for today. Let's get on to intelligence. So today, intelligence is generally considered to be the ability to learn from experience, to solve problems, and adapt to new situations. Psychologists really debate whether intelligence is one general ability or several specific abilities. Some theorists have expanded the definition of intelligence to include things like social intelligence or existential intelligence, and especially the big one is emotional intelligence. Now, there's been some Western attempts to assess such differences, and these began in earnest with the English scientist Francis Galton, who was really fascinated by measuring human traits. Modern intelligence testing began more than a century ago in France when Alfred Binet developed questions that helped predict children's future progress in the Paris school system. And then Louis Terman of Stanford University used Binet's ideas to develop the Stanford-Binet intelligence test. There's also the German psychologist William Stern that derived the formula for the famous intelligence quotient, or our IQ. And then there's David Wechsler's development of an intelligence test called the WACE that helped realize Binet's aims to identify strengths and opportunities for improvement that teachers and others could build upon when dealing with students. Modern aptitude and achievement tests really are widely accepted only if they are what we call standardized, and they're reliable and they're valid. So some vocabulary that we need to keep in mind. Aptitude tests tend to be highly reliable, but they are weak predictors of success in life. One way to test the validity of a test is to compare people who score at the two extremes of the normal curve, both the challenged and the gifted. Now, when we look at studies of twins and family members and adopted children, it all points to a significant genetic determinant of intelligence test scores. And these and other studies also indicate that environment significantly influences intelligence test scores. Psychologists really debate the evolutionary and cultural explanations of gender differences in aptitudes and abilities, and environmental differences are perhaps entirely responsible for the racial and ethnic gaps in intelligence scores. Aptitude tests, which predict performance in a given situation, are necessarily biased in the sense that they are sensitive to performance differences caused by cultural experience. However, The major tests are not biased in that they predict as accurately for one group as for another group. But there's always that stereotype threat that can adversely affect performance, and sometimes appears in intelligence testing among ethnic minorities and women, because because these tests tend to be developed by men and normed on men, and because of that, there in many regions and nations, it's required that for the tests to be used, for example, some education aptitude tests or achievement tests, that they be normed on the population of that country in order to provide a more accurate picture and thereby be more valid and reliable. Now, as a socially constructed concept, intelligence varies really from culture to culture, and thus most psychologists now define intelligence as the ability to learn from experience, to solve problems, and use knowledge to adapt to new situations, as I've already mentioned. Psychologists agree that people have specific abilities, such as verbal and mathematical aptitudes. However, they debate whether a general intelligence, what is sometimes called the G factor, runs through all of them. And the G factor, that's something that was proposed by the theorist Charles Spearman. Factor analysis has identified several clusters of mental abilities. Still, there seems to be a tendency for those who excel in one of the clusters to score well in others. And that's something that has suggested towards the results of L.L. Thurston's ranking of people's primary mental abilities. So there's lots of ways to understand intelligence. Now, evidence that brain damage may diminish one ability but not other abilities, as well as studies of savant syndrome, has led to Howard Gardner to propose his theory of multiple intelligences. And this would include linguistic intelligence, logical mathematical intelligence, musical intelligence, spatial intelligence, bodily kinesthetic intelligence, intrapersonal intelligence, interpersonal intelligence, and naturalist intelligence. Gardner has also proposed a ninth possible intelligence, existential intelligence. Robert Sternberg also proposes a triarchic theory of multiple intelligence, in which he distinguishes among analytical intelligence, which would be academic problem solving, and practical intelligence, as well as creative intelligences. Now, critics note that there tends to be, or seems to be, a general intelligence factor that predicts performance on various complex tasks. And they also note that intelligence really seems to not be enough. Success is a combination of talent and also simply good old-fashioned sweat, grit, working hard. K. Anders Ericsson notes that there is a rule, a 10-year rule. You do something, work hard at it for 10 years, and you will be good at it. You will find success in it. So, distinct from academic intelligence is social intelligence, an aspect of which is emotional intelligence. And the four components of emotional intelligence are abilities, first off, to perceive emotions, so to recognize them in faces, in music, in stories. Two, to understand emotions, to predict them and how they change and blend. Three, to manage emotions, to know how to express them in varied situations. And four, to use emotions to enable adaptive or creative thinking. Those who are emotionally smart are both socially aware and self-aware. And they often succeed in careers, in marriages, in parenting, where other academically smarter people, but emotionally less intelligent people, will fail. They also tend to be happy and healthy. Now, critics of the idea of emotional intelligence argue that we stretch the idea of intelligence too far when we apply it to emotion. Okay? So let's go on now to intelligence testing. An intelligence test assesses people's mental abilities and compares them with others using numerical scores. Aptitude refers to the capacity to learn, and thus aptitude tests are those designed to predict a person's future performance. Achievement tests are designed to assess what a person has learned. Now, Western attempts to assess such differences began in earnest, as I mentioned, with Francis Galton. Francis Galton lived a long time ago. He died in 1911. But he was somebody who was fascinated by measuring human traits. Although Galton's quest for a simple intelligence measure failed, he gave us some statistical techniques that we still use, as well as the phrase nature and nurture to understand intelligence. So the modern intelligence testing movement started at the turn of the 20th century with, as someone who I've already mentioned, French psychologist Alfred Binet. And he began assessing intellectual abilities. Together with Theodore Simon, Binet developed an intelligence testing test containing questions that assessed a mental age and helped predict a child's future progress in the Paris school system. The test sought to identify French school children needing special attention. Binet and Simon made no assumptions about the origin of intelligence, but they did start us on the progress to exploring intelligence, because now we had some way of measuring it in some way. Then Louis Terman believed that intelligence was inherited. Like Binet, he believed that his test, the Stanford Binet, could help people toward appropriate opportunities. And William Stern derived the intelligence quotient, or IQ, for Terman's test. The IQ was simply a person's mental age divided by chronological age multiplied by 100. And during the early part of the 20th century, intelligence tests were sometimes used in ways that, in hindsight, even their designers regretted. They, quote-unquote, documented a presumed innate inferiority of ethnic and immigrant groups, not shared with a heritage of the testers. And that's an unfortunate side effect of the use of testing. And it has led to some guidelines for ethical testing now. Then there's the Wechsler Adult Intelligence Scale, the WACE, together with a version for school-age children, the Wechsler Intelligence Scale for Children, the WISC, and other preschool children. And it's one of the most widely used individual intelligence tests that we have today. It consists really of 15 subtests, and it yields not only an overall intelligence score, but also separate verbal, comprehension, perceptual, organization, working memory, and processing speed scores. The striking difference between these scores can provide clues to cognitive strengths that a teacher or a therapist might be able to build on. Other comparisons can help a psychologist or a psychiatrist establish a rehabilitation plan for someone who has experienced traumatic brain injury or a stroke patient, for example. Now, maybe it's good to go over a little bit of the principles of test construction, because scores become meaningful only when they can be compared with others' performance. And so they must be defined relative to a pre-tested group, a process that we call standardization. Now, obviously, the group in which a test is standardized must be representative of those who will be taking the test in the future. Standardized test results typically form a normal distribution, a bell-shaped pattern of scores that forms a bell curve, what we call a normal curve in statistics. Now, most scores cluster around the average, and increasingly fewer are distributed at the extremes. A performance higher than all but 2.5% of all scores on an intelligence score of earns an intelligence score, for example, of 130. And a performance lower than 97.5% of all scores earns an intelligence score of, for example, 70 or less. Intelligence test scores form a curve. To be the average score near 100, the Stanford, Binet, and Wechsler scales are periodically re-standardized. In the past several decades, the average score really has risen, a phenomenon known as the Flynn Effect. Now, the cause of this increase remains a mystery, although Flynn attributes the performance increase to our need to develop new mental skills to cope with our modern environment. Then there's reliability of a test, and this refers to the extent to which a test yields consistent scores. Consistency may be assessed by comparing scores on two halves of the test. We call that a split half test. On alternate forms, or on retesting, the retest reliability. The higher the correlation between the two scores, the higher the test's reliability. Now, a test can be reliable, but not valid, and so we also need to check the validity of the test. Now, the validity refers to the extent to which a test measures or predicts what it is supposed to. Now, there's a couple ways that we can do this. We can do this through content validity, and this is determined by assessing whether the test truly samples the pertinent behavior or criterion. For example, driving tests should measure driving ability. Then there's predictive ability, also known as criterion-related validity, and this is determined by computing the correlation between test scores and the criterion behavior. Aptitude tests have predictive validity if they can predict future achievement. The predictive power of aptitude scores determines the predictive power of aptitude scores diminishes as students move up the educational ladder. Intelligence scores correlate even more closely with scores on achievement tests. But there's some dynamics of intelligence. that we should be mindful of and that research has shown us a little bit of. For example, in cross-sectional studies, researchers at one point in time test and compare people of different ages. These studies have consistently found that intelligence declines with age because they are comparing people not only of different ages but of different eras. Then there's longitudinal studies, and they follow and retest the same cohort over time. These studies found that until late in life, intelligence remains stable. Longitudinal studies also have pitfalls. Those who survive to the end of longitudinal studies may have been bright, healthy people whose intelligence is least likely to decline. So there's some question about what's going on with the dynamics of development, and part of it's going to depend upon the research design that we use. Research really is complicated by the finding that intelligence is not a single trait, but rather several distinct abilities. So the answers to our age and intelligence questions depend on what we assess and how we assess it. Now, there's a few terms that we can sometimes use. One is crystallized intelligence, and that is our accumulated knowledge. And that will increase as we get older. And then there's fluid intelligence, which is our ability to reason quickly and abstractly. And this tends to decrease beginning in our 20s and 30s. And slowly up to the age of 75 or so, and then more rapidly, especially after the age of 85. So the stability of intelligence test scores increases with age. By age 4, children's performance on intelligence tests begins to predict their adolescent and adult scores. By late adolescence, intelligence scores, though certainly not fixed, are remarkably stable. Children and adults who are more intelligent also tend to live healthier and longer lives. Now, to be labeled as having an intellectual disability, formerly referred to as mental retardation, is when a child must have both a low test score, so on that curve where 100 is average, about a 70 and below would be considered an intellectual disability, and difficulty adapting to the normal demands of living. And these are expressed in 3 ways: in skills, in conceptual, social, and practical areas. So intellectual disability sometimes results from known physical causes, such as, for example, Down syndrome. And that's a disorder of varying severity that is attributed to an extra copy of chromosome 21 in persons with this genetic makeup. People diagnosed with mild intellectual disability might be able to live independently today, and do so much more so than they could many decades ago. At the other end of the spectrum are the gifted. And contrary to the popular myth that they are frequently maladjusted people, research suggests that high-scoring children are healthy, well-adjusted, and usually academically successful. And some controversy surrounds gifted child programs in which the gifted are segregated and given academic enrichment not available to the masses. And some critics note that tracking by aptitude sometimes creates a self-fulfilling prophecy. Those implicitly labeled ungifted can be influenced to become so, denying lower ability students opportunities for enrichment education can widen the achievement gap between ability groups and increase their social isolation from one another. Because minority and low-income youth are more often placed in lower academic groups, tracking can also promote segregation and prejudice, and so we need to be mindful of that. Education really does tend towards inclusion within Canada as well as within the United States. Now, heritability has long been discussed as a large part of the the makeup of intelligence, but when we look at heritability closely, we really look at specifically what genes would go into intelligence, the difference is not that great. So what we seem to see from the research is that intelligence appears to be polygenetic, that there's lots of genes involved in the process. And looking at over 100,000 people and looking at different gene variations, what researchers have come up with was that about 2% of a person's intelligence or educational achievement can be accounted for by gene variability. And one study went so far as to say up to 9%. But even that does not make a huge difference within the variability of people. Overall, studies of children raised in extremely neglectful or enriched environments indicate that life experiences will significantly influence intelligence more than any special gene that a person may have. Extreme conditions such as malnutrition, sensory deprivation, and social isolation can retard normal brain development. And so there is some strong emphasis upon having a rich early childhood to encourage the development of the child's brain early on, and that will result in some gene expression that will help with overall intelligence, because genes and experience together weave the fabric of intelligence. As a side note, epigenetics is one field that studies this nature-nurture meeting place and can be a really fascinating, insightful way of understanding the development of intelligence, particularly in young children. And I think we'll stop there for today.